Hello everyone, welcome back to MrMiers Math Channel. Today in Chapter 10, Day 4, we're going to classify data as quantitative and qualitative. We're also going to choose and create appropriate data displays, and especially important, we're going to analyze some misleading graphs. So let's get started. Qualitative data or categorical data consists of labels or non-numerical entries that can be separated into different categories. When using qualitative data, operations such as adding or finding a mean do not make sense in the context of what we're dealing with. Quantitative data consists of numbers that represents counts or measurements. All right, so in quantitative data, we're actually measuring something. In qualitative data, we're not measuring anything. So if we want to tell whether the data is qualitative or quantitative, basically we just got to figure out, is what we're talking about a measurement or just a count of something, or is it talking about something else? So prices of used cars at a dealership. Okay, that price, which is a number, does represent some kind of measurement. All right, it's a measurement of worth in the eyes, at least, of society. So that is quantitative data. Quantitative data. Jersey numbers on a basketball team. All right, qualitative or quantitative. In this case, we have to figure out, does the number represent a measurement of some sort? And in this case, no. If you're number 7, that doesn't mean you're going to get 7 home runs. You know, that doesn't mean you're going to shoot 7 threes, 7 assists, anything like that. It's just assigning you a number. Okay, so that just means it's a label. Okay, so that when, fans talk about, their favorite player or who's playing out in the field or whatever, they can say, hey, number 7 just made that shot or something like that. So that is qualitative data. It's just a label. Length of songs played at a concert. If some song lasted 15 minutes, that would be a measurement of time, so that's quantitative. Then zodiac signs of students in your class. Surely we could get a number out of that, but the zodiac sign itself is just qualitative. All right, so let's move on now. All right, I'm just going to hit on a couple more of these, and we're going to skip some. So we're going to skip all of these except for the first one here, telephone numbers in a directory. All right, because this is a most often missed question. All right, so the telephone number. So if you have a telephone number, that number, it is a number, but it's not a measurement of anything. Okay, it's not like it's a measurement of how long it takes for the call to be sent out. Okay, it's just assigned to you, so that is qualitative. It's qualitative data. Now, the reason why we're talking about qualitative and quantitative data here is because based on the type of data that we're dealing with, whether qualitative or quantitative, we'll be able to use some data displays over others. So we're going to talk about that next. So choosing the right chart or graph. Okay, there's no hard, fast rule when choosing the right chart or graph, but in some cases, we can't choose a certain type of chart because of the data that we're dealing with. Okay, so, or it wouldn't make sense to choose a type of chart or graph with the data that we have. All right, if we want to compare one set of values with another, we can use bar graph, circle chart, scatter plot, line graph. If we want to show the distribution of a set of values, okay, to understand the outliers, scatter plots, line graphs, box and whisker plots. Remember last lesson we talked about histograms, okay, with the distribution. If we want to show how various parts comprise the whole, pie chart or circle chart, bar graph could do that. If we want to understand the trend over time, in these time scenarios, time is often the x-axis. So like a line graph would be perfect, okay, for understanding the trend over time. Would you want to, if you want to see which values deviate from the norm, we could also see it. We could also use a bar graph or line graph, and then, of course, if we want to establish a relationship between the data, a scatter plot or line graph would be great. There's no hard and fast rule for picking a specific chart, just with some data sets, we can't use a data chart that we might want to use. So in the next example, we're going to choose an appropriate data display and then maybe explain our reasoning a little bit. All right, so for the first part, it has an eye color survey. So we went around school maybe and we collected a survey and asked everybody, like what color are your eyes? Or we looked at somebody and wrote down, a tally of how many people had different colors of eyes. And this is the results from our table. The main thing to think about it when deciding whether we have a qualitative or quantitative data set is in the question that we're asking. Okay, when we ask these people what color their eyes are, we're not measuring anything. Okay, we're just asking and then we're tallying it up. And of course, we're getting a frequency table, but what we were asking was not like some measurement. Okay, so this is qualitative data here. And because it's qualitative data, we can only use some types of data displays. One data display that we might use for this type of data would be a bar graph. A bar graph would be nice and simple to make, and that would show how one compares to the other, and like it just shows what we have in terms of eye colors from this survey. All right, if we take a look at part B, speeds of vehicles on Interstate A and Interstate B. We actually did this type of an example in the last lesson, and what we used was a histogram, and that would be perfect for this. So we could imagine, since there's two different interstates, we could use something like a double histogram, and that would be a great comparison between these two interstates, and then also we'd get a great feel for the distribution and the data for each. All right, moving on. In example 3, we want to talk about how each graph is misleading. And some of these are pretty difficult to miss. Okay, so it's not readily apparent how they're misleading, or we really have to focus on what's being displayed to see what is being misled. And really, although each one of these comes from a textbook, we could find real accurate similarities between these examples that we're dealing with and examples that are, in the media or, social media, news, things like that. So first we have tuition, room, and board at all colleges and universities, assuming across the United States. Here's the academic years, and then here's the average cost. Okay, if we look at this, it doesn't seem to be misleading in any sort of way. We can see that there's a general trend upward in terms of the tuition, room, and board at college over this time period, which is true. Tuition, room, and board continues to go up. One thing that is a little interesting, though, is if we take a look at the 2007 to 2008 school year, and then the 2010 to 2011 school year, holy moly, this looks like that the tuition, room, and board doubled from this year to this school year. And obviously that would be rather frightening. All right, and that's where this graph is a little misleading. Okay, it did not double. Okay, if we would start this graph at 0, we would see, obviously we would see the general increase here, but it's not doubling. All right, let's take a look at B. Now this one's rather tricky as well. What we have is mean hourly wage for employees at a fast food restaurant. So over this time period, we have the wage in dollars per hour. Okay, so we start with, just a general raise, increases a little bit more, general raise, increases much more drastically right here. So that's interesting. All right, if we take a look, because it's not readily apparent, what is wrong with this graph until, wait a minute, we look right here. We're going up by 0.02 or 2 cents. And then right here, it starts to go up by 1 cent. So it changes, okay, which that interval changes, and that doesn't make any sense. Why does this interval change? This should say 9.02, 9.04, so it goes up by the same amount every single time. And if it did say that, we would see this graph would look a little bit more like this. Okay, and then maybe we would see, and maybe that's what they're trying to hide from us, that in this last year, you know, between it looks like 2012 to 2013, the mean hourly wage hardly increased. Okay, hardly increased at all. All right, so that's just some ways that these graphs are misleading. Okay, so that's something that we want to look out for. All right, we got a few more examples here. In the next one, we're going to look at a two-way table. So we want to figure out how many freshmen were surveyed, sophomores, how many students buy lunch at the school, and how many students do not buy lunch at the school using this table. A two-way table is really great to get a lot of information out. So basically, someone took a survey and they asked, you know, do you buy lunch at school, or do you not buy lunch at school? Do you bring your lunch? And then they were also asked or surveyed whether they were a freshman or whether they were a sophomore. We could just fill in this table a little bit more and just find the totals for each one of these things. So how many people in total buy lunch at the school? And we would get 208. How many people don't buy lunch at the school? 138. How many people were freshmen that were surveyed? And we'd get 178. How many people were sophomores? We'd get 168. And then one of the more important parts is how many people were surveyed overall. If we add up either this column or this row, we should get the same thing, which is 346. So 346 total people were surveyed, and of that 346, 178 of them were freshmen, 168 of them were sophomores. The amount of people that bought lunch at the school of these freshmen and sophomores that were surveyed was 208, and then how many that did not buy lunch was 138. And we could use this to do some statistics here. All right. And lastly, in this last example, we're going to fill in this two-way table, and then we're going to use it to answer a specific question. So first, we're going to fill in the totals here. If we add up this column, we get 25, and we get 30, 35, 30, and 25. If we add up each type of shirt that we're looking at, we have 29, 29, and it's the same all the way down. We're getting 29 shirts in these various sizes with these very different color combinations here. So we completed the table, and now we want to take a look at this and use this and figure out how we could alter the amount of t-shirts that we get for next season. Okay, so if we take a look at the next table on the next slide. Okay, this is, by the end of the season, this is how many shirts were actually given out. So now, if we fill in this table here, I'm going to fill in the columns first. We got 20, 18, 14, 5, 8, and then in terms of the color combinations here of the various sizes, we have 12, 16, 14, 11, and then 12 again. And that would be a total of 65. So if we take a look at the difference between the two charts that we had, we bought 145 total shirts, and we only gave away 65. So we have 80 left over, which might be good for the next season, but also we don't want to buy 145 shirts again. Okay, then we're going to have way too much in excess. All right, so in general, for part B here, to answer this question, we just want to order less. Order less colors and sizes in general. I forgot to put and sizes there. But then also more specifically, less of certain sizes here. If we look at the previous table, there was 35 larges that were purchased. Okay, there was 30 mediums, 25 smalls. Not so bad right there. A little bit worse, a lot worse. And then same thing goes for XL and XXL. Okay, we bought 30 XLs. That's 25 that we didn't use. All right, and then the same thing over here. We bought 25. That's a lot that we didn't use. We're not using a lot of those shirts. So I'm saying maybe less large, XL, XXL, and maybe even the black and white shirts. Okay, there was 11 that we gave away, and we had 29. All right, folks, that's all we got today. If you enjoyed this, if you found that helpful, like, subscribe, and share. Thank you, and have a great day.